Welcome back, students. We're on to functions and logarithms today. For today, we're going to get started with equations for circles. So this should be a refresh. Our equation for a circle is x minus h squared plus y minus k squared equals r squared, and r being your radius, h and k being your vertex, which is another word for vertex is your center. So it asks us to find the center and the radius and determine the domain and range. So this is going to be one of those completing the square problems. Yay! I'm sure we just all love to complete the square. So step one of completing the square is we take this and we get all of our like terms together. And by like terms, I mean our x's together. X squared minus 2x, and we're going to leave a blank so we can complete the square. And then we're going to put our y's together, y squared plus 10y, and then a blank to complete the square. And then equals, we're going to actually move that 16 to the other side. And then we're going to leave blanks for whatever we add in to complete the square. So remember, step one is to get those x's and y's together, leave blanks for completing the square, and then move any constants to the other side. So now when we complete the square, we take this middle term, we divide by 2, and we square it. So negative 2 divided by 2 is negative 1. Negative 1 squared is 1. Whatever we do to one side, we do to the other. And that's why completing the square works, because you can just always add to the other side of the equation. This one, we take 10, we divide by 2, 5, we square it, 25. Whatever we do to one side, we do to the other. And now what we're doing is we're putting these into factored form so that we can get it into this standard form of a circle. So what multiplies to give 1 and adds to give negative 2? That's going to be negative 1. Negative 1 times negative 1 gives us 1, and negative 1 minus 1 gives us negative 2. And so it'd be x minus 1, which makes x minus 1 squared. Plus, we're going to do the same thing for y. What multiplies to give 25 and adds to give 10? That's going to be 5. 5 and 5 makes 25 when we multiply, and when we add, it gets 10. So y plus 5 times y plus 5 gives us this function. And then now we're just going to simplify here. Negative 16 plus 1 would be negative 15, plus 25 would equal 10. We have our standard form of our circle. Yay. So now we're looking for what is our center, what is our vertex? Well, our center is going to be h comma k. So now we're just looking in here. H is going to be 1, and k is going to be negative 5. Don't forget that those negatives try to trip you up. We have to do the opposite of them because the negatives are in the actual form. So there's our center, and then our radius, well, this is our radius squared, r squared. So if r squared equals 10, we can solve for r. R would be the square root of 10. And so now just to be able to sketch this graph, I would find my center, 1, 2, 3, 4, 5. And then let's figure out what the square root of 10 is approximately so that we can just get an idea of what we're looking at. Square root of 10 is 3.1. So I'm going to make my radius will be about 3.1 in each direction. So a little bit past 3. There. 1, 2, 3. 1, 2, 3. And 1, 2. Something like that. And then we would have our circle. And of course you could use a compass to make this prettier than my circle that kind of turned out really ugly. But you get the idea there. So now if we're looking at our domain and range, we need to figure out where these are at. Our circle is starting at 1. And so this direction, it's going square root 10 because that's our radius. Same thing here. And here. And here. So our radius is going to start, or so like this point here is 1 minus square root 10 because we started at 1 and we moved square root 10 to the left. And over here, like we're starting at 1 for our domain as well, this would be 1 plus square root 10. If we're going up, where are we starting on our y-axis? 1, 2, 3, 4, 5, we're at negative 5. So this one would be negative 5 plus square root 10, and this one would be negative 5 minus square root 10. We're just starting with where we're at and then moving with our radius. So our domain is going to go from 1 minus square root 10 all the way to 1 plus square root 10. And this would actually be closed brackets because we would hit that point. And then our range is going to be -5 minus square root 10, where we're starting on the y all the way up to -5 plus square root 10. Close brackets because these are points on our circle. And we completed the square. Wonderful. Yay, yes. Okay, so now it wants us to graph on a calculator a circle with a center 0, 0 and a radius 2. Crap. There's not really a way to plug that into the calculator, so let's think about this. It needs to be in a form kind of like this so that I can actually plug it in, but I need to be able to solve it for y. So let's think about our general form. It gave us our vertex. Our h and k are 0 and 0. So we can start with x minus 0, which is just x, plus y minus 0, which is just y, equals our radius squared, so 2 squared. So I'm just using that same formula here. So I know that my equation is x squared plus y squared equals 4. And now I'm able to actually go in and start solving for y so that I can actually graph it into my calculator. So I get y squared equals, or we'll do negative x squared plus 4. And now to get y by itself, I take my square root. So I get y equals the square root of negative x squared plus 4. And this one would be plus or minus because I'm taking the opposite of the squared as square root, which adds that plus or minus in front of it. And this would be something that I could actually graph into my calculator. I could graph in the square root right there of negative x squared. Whoa, sorry guys. I'm trying to watch the video too, and I didn't do that very well. Okay, square root of negative x squared plus 4. And then, so it's plus or minus, so we would also have negative square root of negative x squared, oops, plus 4. And if we fix my zoom, because my zoom is really funky, whoops. Let's go to zoom standard. So as you can see, what this did is it graphed both pieces. So the positive half and the negative half together made our perfect circle. And so circles are actually like split between two parts there. So yay, we did it. Okay, the next thing that we're talking about is inverse relationships. So just a reminder, to obtain an inverse function or relation, we interchange x with y. So we switch x with y. So to obtain an inverse function, the original must be a 1-to-1 function, 1x for every 1y. It has to pass the vertical line test, so that just means that it is a function. But it also has to pass the horizontal line test. So every x has to have its own y, and every y has to have its own x. And we'll have a chance to do an example of this in a second. So this one says, show that the inverse of y equals x squared for x is greater than or equal to 0 is a function, and express the inverse as a function. Okay. So if we're looking at how to find inverse, the first step says that we switch x and y. So inverse is opposite. I switched my x with my y here. And now I'm going to solve for y. So I get y equals, or I guess I'll put it this way so you can see it, plus or minus x. Sorry about that mess there. Plus or minus square root x, because I took the square root of both sides. So the inverse of my function is going to be the square root of x. And we could have looked at our graph of y equals x squared, the original one. That is 1-to-1. It passes the vertical line test, and it passes the horizontal. Okay, so now we are going on to, and so it passed it for greater than or equal to 0. now we are going on to exponential functions. So what we know about our exponential functions are that they are increasing, concave up, the y-intercept is 0, 1, the horizontal asymptote is y equals 0, the domain is all real numbers, and the range is from 0 to infinity. So let's look at this. So we have a horizontal asymptote at y equals 0. So I could just draw that there. And we know the y-intercept is 0, 1. It's increasing, so it looks something like this. That's just for our basic exponential function. It's concave up because it's curved up like a cup. The domain is all real numbers because it's going everywhere from left to right, and the range is anywhere above 0. So you want to be able to know how to graph that off of the top of your head there. Okay, we're now looking at, given the graph of e of x, find f inverse and graph both f and f inverse. So we have e of x, or e to the power of x, and if we wanted to rewrite this as the inverse, so we can rewrite f of x as y. It's the same thing, they're interchangeable. So if I'm looking for inverse, I switch my x and my y. And then I solve for y. Well, to solve for y here, I have to do ln. So ln of x equals y. That's my inverse. So right here, my inverse, f inverse of x, is actually ln of x. And I could graph this. I'm going to write out the key points of the graph first for us, and then we'll go ahead and graph it out. So my inverse is y equals ln of x. That's the inverse of e to the x. So it is increasing. It is concave down. The x-intercept is 1, 0. The vertical asymptote is x equals 0. The domain is from 0 to infinity, and the range is all real numbers. So let's go ahead and just pull this up on the calculator. I want you to be able to do it without, but I want you to be able to see what's going on here. And then that way you can commit this to memory. So we have e to the x, and then we also have ln of x. So let's go ahead and graph these guys. So as you can see, this was the original function, e to the x, very similar to our exponential function. But then ln of x here is that inverse function. So as you can see for ln of x, it's got that y-intercept, and I don't know why this graph printed really funky. It's got that x-intercept there, but it's going more like this. So that one would be our ln of x, and our e of x comes up like this, e to the x. So those are inverses of each other. All right, log properties. These are important to commit to memory. Log of a plus log of b equals log of a times b. So if we're adding them, as long as they have the same bases, we would multiply there. Log of a minus log of b is log of a over b. Log base b of a to the c, we can take that exponent and bring it out forward. C log base b of a. And log base b of a equals c is the same thing as b to the power of c over a. Some people do that like curvy method. B to the exponent of c equals a. It can be written that way. That's what that log actually means. So change of base. Anytime that we want to do a change of base formula, what that tells us is if we have log base b of a, this would be log base c of a over log base c of b. And that would change our base to whatever we desired there. Okay, last example, guys. We got this. Log of x plus log of 3 minus x equals 0. This, our first rule, we see that we're adding, so we can actually switch this to multiplying. They have the same base. So we have x times 3 minus x. And we can distribute. So log of 3x minus x squared equals 0. Now that I have this, I can actually I can do this formula here to write it as an actual equation. Because the natural log here, it's obviously base 10. So we're going to start with 10 to the power of 0 equals this. What's anything to the power of 0? Anything to the power of 0 is 1. And now I can take this and I can rearrange it. I'm going to move everything to the other side because right now my x squared is negative. So I'm going to add that to the other side. Plus x squared minus 3x. And then we have our 1 here. And now that I'm here, I can actually do quadratic formula. I could factor, but unfortunately there's nothing there that's going to factor. So I need to jump into quadratic formula. So I say negative b plus or minus the square root of b squared minus 4ac all over 2a, because there's that imaginary 1 there for a. Now that I have this, I can simplify 3 plus or minus 3 squared is 9 minus 4 all over 2. So this breaks down to 3 plus or minus 9 minus 4 is 5 all over 2. And I could actually plug that in to find my actual solutions. So 3 plus square root of 5 divided by 2. I would get 2.618 as one of them. Then I would do 3 minus square root 5. Whoa, didn't mean to go there. Second quit. 3 minus square root 5 divided by 2. And we get 0.382. And those would be our solutions. And for you, I want you to check and see if those are extraneous solutions or not. Plug them back in, see if it equals 0. If it does, then we're good. If not, then plug it in here, see if they equal 0. If not, then it would be extraneous and it would not be an actual solution. If they do plug in and give you 0, then you're good to go. Thanks for watching.